So we want to prove that if the limit as x goes to infinity of f of x is L, then if you multiply f of x by k, the limit as x goes to infinity will just be k times L. That is, this limit right here, you can just compute this limit and whatever you get, multiply it by k. That is, this k can come out in front. That's what it's saying. Let's go and prove it. Proof. So we're given this. Let's write down what it means. The limit as x approaches infinity of f of x equals L is the same as, now since this limit does equal L, we know that the end that I'm going to refer to exists. We don't have to find it. So, given epsilon greater than 0, there exists an n in the natural numbers such that f of x and L is quite small whenever x is sufficiently large. It's bigger than that n. Okay? That's less than epsilon. Alright. Now, how about I say it's less than epsilon divided by, oh, I guess we have to do this in two cases. First, k is not 0. Okay, k is not 0. Okay, so suppose I choose that for saying that f of x minus L is smaller than something. It's smaller than that. Okay? Right. Well, this means that multiplying both sides by the absolute value k, that means that this is less than epsilon whenever x is sufficiently large enough. And x is sufficiently large. But the absolute value of one thing times the absolute value of another thing is the absolute value of the product of the two things whenever x is big enough. But this is distributing out. This is kf of x minus kl. And this is less than epsilon whenever n is x is big enough. Okay, and we know that this n exists because it did exist. Okay, well, this means this is the same as the limit as x goes to infinity of this, k times f of x is equal to that. So we prove that when k is not 0. Well, what if k is 0? K equal to 0. I just want to see where I wrote. Yeah, so for the first case, k is not 0. Now, the second case, assume k is 0. Okay, well, k times f of x is equal to 0 times f of x, which is 0. So, the limit as x keeps on changing to infinity, k times f of x doesn't budge. It's 0. It's 0. Okay, and the limit as x goes anywhere of a constant, 0 or not, is 0. And that equals to k times L because k is 0. So I did show that The limit as x goes to infinity of this equals KL. And that's all I was supposed to show. The proof is now done. Keep watching these.